Okay, so now we are starting with a new topic. So today the topic of the thing is so the topic of today's lecture is a sequential circuit. So does anyone let me know what is the difference between a combination and a sequential circuit? Any student may answer. If you answer quickly, bonus mark. So what is the difference between the combination and sequential circuit? So what's a combination circuit? Can anyone tell me what is a combination circuit? Anyone may answer. So a combination circuit, the output is a function of inputs only. So let's assume this is a combination circuit. So let's assume this is of output. So basically, let's assume this is an AND gate. Let's assume the inputs is A, B, and C, and the output is D. So okay, now can anyone tell me D is a function? Anyone answer? If someone will answer, and 5 second may get will get some points, and I will note their name. So A, so D is a function of what? Anyone may answer. Quick.
A, B, and C.
ABC.
Who answered me the question? There are two
Thomas.
students. Thomas. Okay, Thomas. I'm now noting your name. The other students, please let me know your name. What is your good name? The second guy,
James.
James. So I'm now noting your name. So if you have more like contribution towards the lecture, so you may get bonus mark towards the final. So now in this case, so we have this. This is a function of A, B, and C. So the output is a function of the inputs only. So this is a combination circuit. Okay. Now we have a sequential circuit. So now in a sequential circuit, so now what I'm going to do, so the sequential circuit, and what are the example of combination circuit? The example of combination circuit is AND gate. So examples. What are the examples of combination circuit? Is AND gate, OR gate, multiplexer, demultiplexer. All the topics that we covered until now are combination circuit. All the topics, encoder, decoder, priority encoder, all of them are combination circuit. Now, what's the sequential circuit? So sequential circuit, the output is not only a function. So output is a function of inputs, but it also depends on previous state. And I will explain this with an example. So let's assume if we have this, can you see what I'm going to do? So now I'm going to take a screenshot of this. So now let's assume I will give this one an example. So let's assume if there is a block diagram. Okay, I'm not drawing the internal of the block diagram. I'm not drawing the internal of the block diagram. I'm just like drawing a general circuit. So we don't know what is inside the block diagram. So let's assume the inputs is K, P, and J, and the output is T. And let's assume if this output T is feedback back to the input, maybe some of the inputs. So this is a combination circuit or sequential circuit. Why it is sequential? Why it is sequential? Anyone may answer.
Because the output is part of the inputs.
The output is a part of the input. So output is a, what's your good name?
Thomas.
Thomas. Second point. Second point. Not it's not. I will gather these points, and based on these points, I will give some points towards the final. So why it is sequential? The reason, and anyone one may answer. This offer is for all students, not only for Thomas and not only for James. So why it is sequential? So the sequential is this: the output is now there is a feedback. So that's the reason this is sequential. Okay. Do we have a feedback in the above circuit ABC? Anyone may answer. Do we have feedback for the AND gate? No, we
No.
don't have any feedback. No. So also we don't have any feedback. Got it or not got it? So this is the difference between a combination circuit and a sequential circuit. Any question? Any question? Okay. So this when there is a feedback, so there is a feedback, so there is a combination circuit or a sequential circuit. Any question? So if you go through there, then now what is a sequential circuit? Sequential circuit use a clock as an additional input. And in change in the memory elements are controlled by the clock. Changes happen in discrete instant of time. I will explain this with an example. So basically what we do, so now let's assume what is this thingy. So now for this we have a clock here. Now if you look at the clock here, now can you see here the clock? What is a clock now? In sequential circuit, we need to know the clock. So first we need to understand the clock. So if you look at this clock, okay, what is a clock? It is a train of pulses. So first it becomes 0, then it becomes 1, then 0, 1, 0, 1, 0, 1, and this goes on, this goes on. Got it or not? So can you see here? Now what I'm going to do, so now if you look at here, so now if you look at here, this is a logical zero. What is this thing? We have one here, we have one here, now we have one here. One is which color? Anyone may answer. Quick.
Green.
What is your good name?
Abir.
Abi. So I noted your name now. So green is, so now I'm going to have the blue color. So 0, 0, and 0. So okay. So during this time, the clock has a value of 0. Okay. Now, if you look at here, anyone may answer for bonus marks. What is this thing called? The red one. Can you tell me what is this thing called? So this thing is called as rising edge. Anyone may answer. 5 seconds. When the rising edge will occur? When we make a transition from what? 0 to 1 or 1 to 0? Rising edge means what?
0 to 1.
What is your good name?
Ghala.
Voila. I noted your name. If you are noting your name, it's a good sign. So there is a rising edge, so it means 0 to 1. So until this point, Thomas has got two points, James 1, Abir 1, Ghala 1. And I will collect these points, and based on these points, I will give the bonus marks at the end of the final and in the final. Okay, now if you look at here, what is this edge called? Can you tell me so I can take the
Falling edge.
Falling
falling.
edge.
Yeah, what is your good name? The first one who answered. The guy who answered.
Zafar.
Zafar. I noted your name, Zafar, now. Thank you. So now we have, if you look at here, so this is called as a falling edge. And falling edge will make a transition from what? Help me.
1 to 0.
1 to 0. Very good. 1 to 0. So this is how it works. So this is from 1 to 0, and then we can say, so if there is a green thing, it's a okay. So this green thingy is called as green. It's called as positive pulse because it's 1. Positive pulse because it's 1. And the blue thing is called as what? Help me.
Negative.
What is your good name?
Abir.
Abir. Abir has the second. Okay. Negative pulse is 0. So this is how it works. So now this we have a clock, and based on this clock, so we have a positive pulse, and now we have negative pulse, and now we have a transition that we call it as a rising edge of the clock, or we call it as a falling edge of the clock. So these are 4 different thing of them. Okay, now if you look at here the clock periods. So now we call this as the clock period. So this is my clock period. Okay, now if we have so how can we calculate the clock period? Anyone may answer. How can we calculate the clock period? Help me. Anyone may answer. How can we calculate the clock period in nanosecond or in time? Anyone may answer.
From one rising edge to the next.
No. So clock period is equal to 1 divided by f. And f is your frequency. Got it or not got it? So let's assume we have a frequency of 1 megahertz. If we have a frequency of 1 megahertz, anyone may answer. What will be the clock period in 5 seconds? Anyone will answer in 5
1
seconds.
times 10 to the power 6.
What?
Is it 1 times 10 to the power of 6?
Yeah. Then what will be the clock period in microsecond?
1 microsecond.
1 micro.
Yes. What's your good name?
Thomas.
Thomas, and the girl?
Ghala.
Voila. Vala has now 2. So 2 answers from Vala, 3 answers from Thomas. So how can we calculate the clock period? So the clock period is equal to 1 divided by 1 megahertz. And this is actually 1 divided by 10 to the power 6, which is actually 10 to the power minus 6, and 10 to the power minus 6 is equal to 1 microsecond. Got it? Let's assume if we have a different clock frequency. F is equal to, let's assume, 2 megahertz. What will be the clock period? 5 seconds.
0.5 microseconds.
Thomas, yes, you get one additional answer. So you got one additional. So clock period will be 1 divided by 2 megahertz, and it is actually 1 divided by 2 multiplied by 10 to the power 6, which is actually 0.5 multiplied by 1 divided by 10 to the power 6, which is actually 0.5 multiplied by 10 to the power minus 6. It is actually 0.5 microsecond. Got it or not got it? Any question? Any question? Okay, now if we have So now we have two things. So now if you look at the next thing, so now these are two clock periods. The first clock period is in green color and the second clock period is in red color. What is the frequency of the green here in this example? What is this frequency? Anyone may answer. And the red one, what is F1 and what is F2? Anyone may answer.
1 microsecond.
F1 what?
1 microsecond.
No, sorry.
2 microseconds.
1 picosecond.
No, the clock period is 1 microsecond, but we want to calculate a frequency. So now, if in this example the frequency is 1 megahertz, because the clock period is. So can you see here the frequency? If the frequency is 1 megahertz, so the clock period is 1 microsecond. In the second case, if the frequency is 2 megahertz, the clock period is 0.5 microsecond. So what will be F2? So F2 will be actually the frequency is now 2 megahertz. Okay, now if you look at here, what is your observation? Anyone, if someone will tell me the observation, he may get some points. I will note his name or name. Yes, anyone. What is your observation here? So now let's do. I'm saying question. What is your observation? Looking at these two figures. Yes.
Is the clock period and frequency inversely proportional?
Inversely proportional. What is your good name?
Mubin.
Mubin. Yes. So basically, now we have Thomas with 4 answers, James with 1 answer, Abir with 2, Khala with 2, Zafar with 1, and Mubin with 1 answer. Okay. So the observation is that here. So now what we are going to do, so it means it. So the observation is this: say the frequency and the time period are inverse of each other. Okay. So now can you see they are inversely proportional to each other. So it means that higher the frequency, then what?
The lower
Clock
the
period.
period.
Huh?
Lower
Clock
clock
period will be
period.
what? Shorter or longer?
Shorter.
Clock period.
Shorter. It will be shorter.
Shorter. And if the lower frequency, clock period will be longer. Can you see here? This is lower frequency. So this F1 is now. So in this example, F1 is at lower frequency. And then we have the higher frequency. Any question? Any question?
No.
Okay, now we proceed further. So now, okay, now sequential circuit require clock. Combinational circuit does not require clock. Okay, why we are studying clock? Why we are studying clock? So we need to know the clock. So until now, we have not studied that clock has 4 thingy. We have a positive pulse, we have a negative pulse, we have a rising edge of the clock which make a transition from 0 to 1, and a falling edge of the clock we have a transition from 1 to 0. And clock has some frequency. And if clock has some frequency, so it means higher the frequency. So if the frequency is higher, so the clock period will be longer. If the frequency is lower, frequency is higher, clock period will be shorter. Got it or not got it? So this is how it works. So now this is also the example. So this is some examples I'm not going to do. So please go through these examples in this thing. Now, the first basic building block of a sequential. So we need to first study the basic building block of a sequential circuit. Let's assume if you want to have the first basic building. What is the first basic building blocks of a combinational circuit? Anyone may answer. What is the basic building block of a combinational circuit? Anyone may answer.
SB?
No. Anyone? The basic building blocks for any combinational circuit are the gates, like the AND gate, the OR gate. These are the basic building blocks, and we constitute bigger circuit out of these gates. So if you say encoder, so for encoder we need some gates. What kind of gates? That you can connect the gates in some particular fashion. So what is the basic building block? One of the basic building block is an SR latch. So what is an SR latch? Now this is a block diagram of an SR latch. Can you see here? Now if you look at the SR latch, this is an SR latch. It's a memory element that can store either a 0 or 1. Okay. SR latch has a 2 cross-coupled NOR gate. Can you see here? This is a 2 cross-coupled NOR gate. Can you see? Clear or not clear? 2 cross-coupled which gate? NOR gate. Okay. Now if you look at the latch at the block diagram, what are the inputs and what are the outputs? Can anyone tell me? Anyone may answer. What are the inputs and what are the output? Anyone may answer. I will note down the name.
R and S are
Which
the
is R and
inputs.
S.
Q and Q bar are output.
Yeah. So I will not give you any points because you talk a lot. So basically you answered me a lot. So okay. Now if you look at here, so these are two R and S which are the inputs and Q bar are the outputs. Got it or not got it? So these are the two inputs. Okay. What does it's a cross coupled NOR gate. So can you see here there are two inputs S and R. Okay. What is the color for S, which is red? What is the color for R? Blue. So we have two inputs. So if you look at the block diagram, so the block diagram, it shows me the inputs and the input is R and S. So these are the inputs. The outputs are Q and Q bar. Two outputs Q and Q bar. What is the color for Q? Which is the black. What is the color for Q bar? Which is the green thingy. So now we are just analyzing. We are just analyzing that what are the inputs of a latch and what are the outputs. Now we have any question? Any question? Clear or not clear?
Clear.
Yes, I need an answer. So very quickly. So can you see here? Okay. Now the question now arises. Now the question arises if we say that actually this is in S and R. So the question arises. Okay. Now the inputs for this latch is R and S, and the output is Q and Q bar. So we have secure. This is an SR latch. This is an SR latch. Is this circuit combinational or sequential? Anyone may answer.
Sequential.
Okay, now the question is, anyone, if we answer the second question, I will note down his name. Why it is a sequential circuit?
Because we're taking the final output as an input
How do you know it?
from the diagram.
How do you know it? Can you tell me why? Anyone? Any other one?
One of the input for the NOR gates is Q, and for the other one it's Q bar.
Mm-hmm. And then?
And then
No.
it keeps
It keeps what? Help me. Yes, yes. Good. Very good. Please try to answer. Very good. Mm-hmm.
it keeps going back, like
Very
the
good.
output keeps
Yes. What's your good name?
Sidra.
Sidra. So I'm not noting your name. So now Sidra said that there is a path from the output to the input. So it means there is a feedback path. So since there is a feedback path, yes, is this combinational circuit sequential or sequential? It is sequential. Yes, it is sequential. But why it is sequential? Because there is a feedback path from the output back to the input of this circuit. So this is, and there is not only one feedback path. There are two feedback paths. So that's the reason that this circuit is why, because there is a feedback path. You will not see any kind of these feedback path in any kind of combinational circuit. In AND gate, we do not have any feedback path. This is the block diagram of an AND gate. Do we have a feedback path here? No. There is no feedback path in an AND gate. That's the reason there's a combinational circuit. Even in the marks, if you look at the encoder, priority encoder, all the combinational circuit does not have any feedback path. Any question? This is clear?
Professor, how does this circuit actually work? Because for one side to complete, the other one has to complete it, and similarly goes for the other side as well, right?
So I know, because at this point of time we are just like talking about like what's the behavior of this, how this will work. We will study and analyze this. We will analyze this circuit now. I'm now going to analyze it one by one. I'm making like it very. I'm just like making an argument that okay, what does latch on? It's a combination of circuit. What's the behavior? What will be its functionality? I will explain it later on. I have not explained SR latch at all now. Got it or not got it? Any question? Did you get my answer?
Yes.
Okay. Now we are going to analyze this circuit. Now this is our objective, to analyze, and now I'm here to analyze this circuit. Okay. Now if you look at here, this SR latch. Now this is my SR latch. Got it or not got it? So what I'm going to do? So basically, what I'm going to do? Okay, maybe I will do something more. So okay. Now this is an SR latch. Okay, now if you look at the block diagram of this SR latch, so the SR latch will look like this. So this is what are the inputs? Can anyone tell me what are the inputs to the SR latch? Anyone? R and S. What are the outputs? Q and Q bar. Got it or not got it? Now if you look at here, if the input is R and S and Q on Q bar, so how many combination will be there? Anyone may answer. How many combination will be there?
4.
Anyone? Hmm?
4.
Yes. 4. What is your good name?
Shady. Or Rex.
Hmm? What? Your good
Shady.
name? Rex? You're Rex? Yes.
Yes.
Yeah, Rex. So you can tell me Rex because she is very hard for me to like. Okay. So now if you look at here, R and S there are 4 combinations. So 0, 0, 0, 0, 1, 1, 0, and 1, 1. Got it or not got it? So now we want to analyze it. What will be our output in this case? So what we are going to do? So we have this combination. So we have Q and Q bar. Got it or not got it? Okay. Now we want to see for one combination. So I'm now looking at. So okay. Now what I'm going to do? Now I'm making a red color. Why I'm making a red color? So I'm now interested in this combination. So for the red color, let's assume R is 1 and S is 0. So my R is 1 here and my S is 0 here. Got it or not got it? My R is 1 and S is 0. Okay, now we have a top NOR gate and the bottom NOR gate. What will be my output? If anyone will answer me this question in 5 seconds, may get some points. Anyone may answer. What will be the value of Q and Q bar? So no one answered.
Q is 0. Q bar is 1.
Q is 0 and Q bar is. What is your good name?
Abir.
Abir. So Abir got the third answer. I have noted. So it's your third answer now. Very good, very good. So can you see here? Now if you look at here, for the top NOR gate, if any input, so remember, we remember, if any input to the NOR gate is 1, the output will be 0. So what will be Q now here in this case? It will be 0. Why? Because if any input to the NOR gate is 1, okay, now please look at the red color. I'm now writing in the red color. So Q will be 0. And now since Q will be 0, so this 0 will come from here because there is a feedback path. So 0 will be here. And 0 plus 0 whole bar. So what is 0 plus 0? So okay, can you see here? So now we can say this for this NOR gate. So we can say okay, 1 plus Q bar. So because this is 1 plus Q bar. What is 1 plus Q bar? Any input to the NOR gate is 1 plus Q bar whole bar. And 1 plus Q bar is actually 1 bar and it will be equal to 0. Got it? So now this is 0. And now if we feedback here, so now at the bottom gates, we can say 0 plus 0 whole bar. If you look at 0 plus 0 whole bar, it will be 0 bar and it will be equal to 1. So the Q bar will be 1. Any question? Any question? Is clear or not clear? The red color. Okay. Now I'm going to write the comment on it. What's my comment? My comment. Okay. So this is called as, because, okay, what does, no, please look at here. In this case, R is 1. R is 1. R stand for what? Set or reset? R stand for what? Set or reset? R stand for reset. So the comment is this: what we are doing? We are resetting Q. We are resetting Q. So when we are resetting Q, this implies that Q will be 0, and since Q bar is the opposite of Q, so it will be 1. Any question? Any question? Got it or not got it?
Professor, can you repeat it?
Yeah. What should I repeat it? What should I
Actually,
repeat?
I
Yes.
don't understand how, like, when we say 0, 1, it means reset Q. Is it like they're from before, or is that what we were inferring?
No. Okay. Did I see what is the value of Q now? So it means that if Q is equal to 0, it means it is reset. And if Q is equal to 1, it means it is set. Now you understood it? Any question?
Yes, thank you.
You got it now?
Yes.
So it means we are resetting Q. So we are resetting Q, so it means that Q is 0. Got it or not? Now what I'm going to do? Now I'm going to try another combination. So I'm not going to try another combination, and now I'm going to try this blue combination. So for blue combination, what I'm going to do, so I'm now going to have this thing. This is my blue combination. And what I'm going for this blue combination, I'm copying and paste as you do it in your homework. Okay, so this is now I'm going to do in the blue combination. When we do the blue combination, so now in the blue combination, what is the value of S? Anyone tell me? What is the value of S now? Help me.
1,
And R?
0,
0. What's your good name?
Sidra.
Sidra. Okay. Sidra has now 2 answers for me. So it's 0. Okay. What will be the, now you have 5 seconds to respond. What will be the value of Q and Q bar?
1 and 0.
1 and 0. What's your good name?
Reem.
Reem. Very good, Reem. Okay, now if you look at here, so since we have this, okay, please again, this is the same thing, but now in this case, since we have 1 and 0, so we have the same argument. So can you see here now? What is this thingy? What is this thingy? So this is actually 1 plus q, and this thing is actually 1 plus q whole bar, and 1 plus q is anything is 1 bar, and it is equal to 0. So q bar will be 0, and then will be 0, and this will be 0 plus 0 whole bar will give me 1. So now q is 1 and q bar is 0. So q is 1 and q bar is 0. What should be my comment here now? What should I write here? Comment.
Set Q.
That's Q.
So Sidra answered. So Sidra 3. So you got the third thing. So we call this as set q. Very good. Very good. I really like the thing. Okay, now at this point of time, now we have analyzed the behavior of a latch. Okay, one student asked me that why we are using latch. So now we are going to analyze the behavior of the latch. Now we want to see the third combination. Okay, and now we want to see the third combination. And what is that third combination? Now I'm using another color for that. And now I'm using the black color for it. I'm now using the black color. So now I'm using the black color. I will give you 5 seconds. 1 and 1. What will be Q and Q bar?
0, 0.
What's your good name?
Abir.
Abir. So it's your 4 response. Okay, so because if any input to the NOR gate is 1, output is 0. So it's 0 and 0. Okay, now $1 million question. So Q is now 0 and Q bar is now 0. So what should I write here? In the comment.
Is it invalid?
What's your good name?
Moving.
Mubin. Yes, you're right. We call this as invalid combination. And being as a designer, you should design a circuit in a way that this invalid combination does not happen at all. Because this R and S may be the input from some other block. Maybe there is some, so maybe there's some other block. There is a block here. So you should design this block in a way that, and the output of this block is something maybe. So this block is now depends on the input. So this, you should design this block in a way that this 1 does not happen at a time, because it will cause me an invalid combination. Because what's our objective? Either we are resetting Q or we are setting Q. Any question? Is clear or not clear? What about the fourth combination? Yes. What about the fourth combination? Can you tell me?
1 and 1.
Okay. Now, your answer is wrong. I'll explain this why. Your answer is wrong. Can you, if it's anyone will tell me the answer, may get some points. Anyone?
1 0.
No. Anyone?
It could be 1, 0 or 0, 1.
No. I'll explain it. No problem. I'll explain it. Okay. Now I'm using another color for that. So the color that I'm using is now the orange color. So this is actually now 0 and now this is 0. Got it or not got it? Any question? Okay. Now if you look at here, And please remember, to understand this thing, so I will explain this in the next slide, because you are why, because this case is a little tricky case, so I'm not making it a big one. So basically, why I'm getting a big one, because this is a special case. This is a special case. And since similarly also checking the checking the exams of AU students, when the students are doing a lot of chat GPT and blah blah blah, it's very difficult. It's also a very curious case. So now we say 0 and 0. Got it or not got it? So now we are considering this fourth case. This is the orange one, 0 and 0. Why I'm going to do this? I will explain this with an example. Let us assume that this is, I call this as QT. QT. And I call this as, so this is my QT, and I call this as, so this is what do we call this? I call this as QT, and I call this as Q bar T. Got it or not got it? So I'm now defining two inputs, two outputs. What is my QT and other is my Q bar T. I'm just making some some name to the thing. Okay. Now, if you look at here, this QT will come here. Got it or not got it? So QT will come here. Got it or not got it? Any question? And this Q bar T will go here. So this will be QT bar. Got it or not got it? Any question? Okay, now why I'm going to this, I will use different colors. So basically you should know it, because you know why this is not a good thing, but let's see. Okay, now what I'm going to do, I'm now using different color. And why I'm using different color? Because these colors are always good. So let's assume we have this thing, we call this as QT. QT is which color? QT is which color?
Pink?
It's red color, okay. And then Q bar T is your green color. Okay, since this is Q bar T, so now I'm using the green color. So now this is go here. What will come here? This is actually Q bar T. Got it or not got it? Okay, now I'm using the red color. Here, what will come here? Anyone may answer. Any question? Okay, now what we want to do, so okay, since this is QT, it means that now, I'll explain this with an example. Let's assume this is the state. This is the state. Okay, this is a state, and Thomas is currently sitting. And this is the current state of Thomas. So Thomas is currently sitting. In the next cycle, this is actually QT plus 1. So QT plus 1, it depends on the previous state. So now what we are going to do, okay, now what will be the output of new QT? So what will be QT plus 1? So QT plus 1, so now we are computing QT, so what will be QT plus 1? Can you tell me? What will be QT plus 1? Anyone may answer.
1.
No. QT plus 1 is actually very, very important. This QT plus 1 in the next cycle, so this will be equal to what? 0 plus what? QT bar whole bar. Am I right? Any question? Clear or not clear? So now if you see anything 0 plus this is actually QT bar double bar. So QT plus 1, so in the next cycle, so QT plus 1, and if you double bar here, it is actually QT. So now we have the next state. So it means that QT plus 1 will be the same thing as QT. And now we are going to have the another thing. Now we want to compute QT plus 1. This is the next state. So QT plus 1 whole bar is equal to what? Anyone may answer. What should I write here? Anyone may answer.
QT
Yes?
bar plus 0.
No. Because please remember, for this QT plus 1, this is my output. For this we are considering the top gate. And for the QT plus 1 bar, what will be the input? Anyone may help. It is what? 0 plus QT and then whole bar. And if you look at here, so it will be actually QT bar. Got it or not got it? Qt bar. So Qt plus 1 will be equal to, so Qt plus 1 will be equal to Qt bar. So now this is a special case. So this is a special case. So what will we do? So now if we want to do that, so now we have another notion of, so can we see, it is actually Qt plus 1 and Q bar t plus 1. So the next state will be actually Qt and then it will be Qt bar. It means that it will no change. We also call as no change, or it we call this as retain its value. Any question? Clear or not clear? Clear or not clear? No one is answering me.
Clear, Professor.
Okay, very good. Okay, now there will be a lot of examples, and there will be a lot of examples. I will explain this with another lot of examples. In a lot of examples. Got it or not got it? Okay. Now, what we are going to do? And now what we are going to do, because what I'm going to do, so I will give this with a lot of examples, and examples are always good. Now, can you see here? Okay. Set Q. We are setting Q. If you are setting Q, what should be the value of S now? We are setting Q. Anyone? What should be the value of S? S should be 1 and R is 0 because we are setting S1 and R is 0. So basically, can you see here? The output will be 0 and this output will be 1. So we are setting Q. And then we store 1. Please look at here. Now in this case, okay, initially, now this is my time t1. This is my time t1. I'm time in time t1. I'm setting the flip flop, the latch. And what I'm doing to do, okay, now what is my assumption? So now I will explain this one thing. So initially we set Q. We set Q, R is 0 and S is 1. So Q will be 1 and Q will be 0. Okay, in the next cycle, let's assume R is 0 and S is 0. So when both of them are 0, so it is 0 and it is also 0. So when both of them are 0, so what will be the output? So this 0 will come here. So this 0 will come here. Got it or not got it? And then we are resetting Q. If you are resetting Q, what will be the value of R? Can you tell me? What will be the value of R? Anyone may answer. And
1.
what S? What is your good name?
Sidra.
Sidra. It means that the R will be 1 and S will be 0. And if you look at here, and now let's assume R and S becomes 0 and 0 thing. So what will be my output? So my output will be now, my output will be 0, 1. Can anyone see any observation? What is observation here? Okay, now in this case, both input are same or different? In both case?
Same.
Same. But if you look at the output are same or different? We have same output, but the output are same or different?
Different.
Output are different. So this is a special case. So if S and R are 0, 0, so we cannot predict output. We predict the output depends on the previous state. You got it or not got it? Okay, so it depends on the previous state, and the previous state was what? What was the previous state here? The previous state was 1. Q was storing 1, so the previous state was 1. Here, Q was storing 0, so the previous state was 0, so it was storing 0. Any question? So it means that now RNS is equal to retain the previous state. Got it or not got it? Any question? And I will explain this one in an example. I will explain this one in an example. I will explain this one in an example. And because examples are always good. Examples are always good. Okay, now. And now please remember, anyone who will answer me this thingy, so this will be, they may get some points here. So I'm now, I need, and because I'm going to, and this is very simple example. There are very simple example. Okay. So let's assume we have S and R. And this is actually Q and Q bar. 1, 0. 0, 1, 0, 0, 1, 0, 0, 0, 1100. Okay. Okay. Anyone may answer. If S is 1 and R is 0, what should my output? 5 seconds.
0, 1.
No. Sorry. So now we are doing comment. So what is my comment here now? So basically I'm now using the black color. So for the black color. So the black color means the comment is set Q. Set Q. We are setting Q. When set Q, so Q will be 1 and Q bar will be 0. Any question? And there is again the black color. So black color, it's very simple. We are also again set Q. Since you are setting Q, so Q will be 1 and Q bar will be 0. Any question? Any question? Now look at the red color. Anyone will answer in 2 seconds. What will be the output?
0, 1.
0, 1. You set it like after 2 seconds or now. So it is 0, 1. What is my comment?
Reset Q.
Q.
Reset Q. So we're resetting the flip flop. Because now we are resetting. Because remember we are resetting the Q. Okay. What about this 0, 0? The green one. What will be the output? Anyone may help.
0, 1.
Why 0, 1?
Because of the previous
What is your good name?
Abir.
Abir. Very good. Very good, Abir. Very good. You have now 5 answers. Okay. So can you see here? Now it will store the previous value. So now can you see the previous value? It is 0 and then it will go 1. Again 0, 0. Now I'm now going like this. What will be the output? Anyone may answer?
1 0.
1, 0. What's your good name?
Zafar.
Zafar. Second response from you. So it will be the previous case. 1 and 0. Now if you look at this green one and if you look at this green one. Okay, for this green one, the input is 0, 0, but the output in the first case, the output is 0, 1, and the second case, the output is 0, 1, 0. Got it or not got it? Any question? So for the green one, so it means that for the green one, input are same, but the output is what? Different. Why? If anyone will answer me this question, why, I will note his name. Why? Why? It's not
Because
about
it's the
like,
base case and it needs the previous input.
why? Why? No, yes, it stays a previous, but why? Why? It's not about like you're sitting in an exam and you're asking ChatGPT. And I see a lot of patterns. I see a lot of patterns on the exams. But there is a lot of similarity. I give it to things and it analyzes me. And I have checked it in that scenario.
It's because in the first case, it's reset Q, and in the second, it's set
No,
Q.
no. Because the reason is this why. I'll answer you. The reason is that there was a feedback path from Q and Q bar T. Remember the special case that we did here. The special case that we did here, it was that special case, this one. Because of this feedback path. So it is retaining its previous value. And that's the logical argument for this. So this is now qt plus 1. And please remember, this is very important now. So we have some time, the notion of time. So this is actually, can you see here? So this is actually t0. So let's assume this is my t0. So this is t0. Then we have t1. Then we have t2. Then we have t3. Then we have t4, t5. So we need to know the notion of time. You got it or not got it? So if the input is 0, 0, so it means if the input is 0, 0, s is 0, and r is 0, so what will be qt plus 1? So qt plus 1 will be qt. Got it or not got it? Any question? Okay. Now, $1 million question. Please remember, this is a very $1 million question. If it is 1, 1, the orange one, what will be my output? Anyone may help.
0 0.
0, 0. Okay, this is 0, 0. So this is actually, what's the comment? It is an invalid combination. Yes. But now anyone who will answer this question, okay? Anyone who will answer this question. So if anyone will answer this question, will get 1 bonus mark. What will be my, if it's 0, 0, what will be my output?
Invalid?
No, because if it is 1, 1, it is actually 0, 0. But if the input is 0, 0, what
One
should my
zero.
output be? Huh?
1 0.
0.
Why 1, 0? No, it is 1, 1. Please, 1, 1, we covered the 1, 1. So when there was 1, 1, the output was 0, 0. Got it or not got it? But if we have 0, 0, the input is 0, 0. What should be my output? Anyone may answer.
Does it go to the one before the invalid?
No. Anyone may answer.
Is it 1, 1?
No. So basically, what does 0, 0 means? It retains the previous value. So what is the previous value? 0, 0. But it will not be 0, 0. So if this is 0, 0, it means we do not know. We will not know the output. Why? I will explain this curious case. And this curious case is very complicated case. Why this is curious case? It all depends on the pattern. Why? I will explain this thingy. And this is a very curious case now. Okay, now if you look at here, this is an invalid operation. So we know that it is an invalid operation. So there is an invalid operation. So the invalid operation will occur when r is equal to 1 and s is equal to 1. When r is equal to 1 and s is equal to 1, both output will be 0, 0. We already discussed this case. Got it or not got it? Okay. Let's assume after this time, when r is 1 and s is 1, after this time, let's assume s becomes 0 and r becomes 0. So s is now become 0 and r also became 0. Both of them become 0, 0. Got it or not got it? Now it depends on, okay, now these are two scenarios. If q bar arrives first, okay, I will next one an example. So this example is very good. Let's assume we have two students. Okay, we have two students. The first student is Thomas and the other student is Gala. Please answer me. Thomas and Gala.
Yes, sir.
Speak. Okay, now who arrives first? Thomas or Gala?
Thomas.
Thomas. So it depends on, now the output depends on that who arrives first. So now we have two gates here. We have the top gate and the bottom gate. So if q bar arrives first, so q bar arrives first. So if q bar arrives first, it means that the bottom gate is now faster. So now it means r is 0, 0. So bottom gate becomes faster. So in the bottom gate becomes faster, this 0 will go here. This 0 will go here. And it is 0 plus 0 whole bar. This will become 1. Q will become 1. And this q will come to the down one. So this q will travel here. And what will be the output? 0 plus 1, 0. So this will be 0. So now in this case, the output will make a transition. So q will make a transition from 0 to 1. And q bar will make a transition from 0 to 0. Got it or not got it? Now, let's assume. So now in this case, now I am assuming that Thomas arrives first, which is actually q bar and which is the bottom gate. Now we assume that q arrives first. And what is the initial value? The initial value that is stored here is 0, 0. Now we are assuming. So now let's assume q arrives first. So when q arrives first, so this q will go here. So it will be actually 0 will come here. Got it or not got it? So this 0 will become 1 and this goes 1, it will become 0. Now can you see the output? Here, the output, okay, in this case, if q bar arrives first, the output will be 1, 0. And if q arrives first, the output will be 0, 1. So this is called as the unpredictable state. So this is very important. So the curious case in SR latch is this. If we have a 1, 1 and that 1, 1 is followed by a 0, 0, we cannot predict output at all. Any question? Any question? Clear or not clear?
Professor, is there a case where both arrive at the same time? Or
Even
no?
this is called as a very race condition. I will explain this with an example. Okay, Sidra, you asked a very good question. You asked a very good question, and I will answer your question in a way. Let's assume that you have a musical chair, okay, and there are two students, and there is only one chair. I hope I answered your question.
Yeah, so one of them has to
One
arrive
has to
first.
arrive first. Only one student will sit first. And basically, if you look at the digital systems, all the circuits are like working in the fraction of nanoseconds. And if you go from this nanosecond, so I can say, oh, who responded one? So you responded in like 0.3 seconds or 0.5 seconds. So basically, the circuits are working in nanoseconds duration. So it is impossible for two signal to arrive at the same time, even if it arrives at the same time. So what one will dominate? I hope I answered your question, Sidra.
Yes, Professor. Thank
It was
you.
a very valid, very good question. It was a very intelligent question. Very good, Sidra. It means that you are paying attention. I really like it. We have same input but unpredictable output. Got it or not got it? Okay, now what are you going to do? So now we are going to do this thing, and now I'm going to explain another thing. So we did this. Okay, we covered this thing or no? Okay, we covered this thing. Okay, now we are covering the other thingy. So now we are covering the other thingy. So what I'm going to do? So now, but I'm not using the same color now. So what I'm going to do? I can take a print screenshot of this, and then I will see its output. So this is actually a rectangle. I'm going to do. I'm not using any color combination. I'm not using any color combination. I'm just like to see the output. And please, I need your attention. So anyone, okay, the student who didn't. So basically, this is now an opportunity for the student who didn't answer. This is only for the student who did not answer. So they may get a chance to get a bonus points. So Thomas will not speak. James, Abir, Ghala, Zafar, Mubin, Sidra, Rex, and Dream, you will not speak. This is only for opportunity for the students who did not contribute until now. So if anyone will answer other than these students, they may get some points. So we have Q and Q bar. Okay, 1-0. What will be the output? Any students other than the student that I mentioned? Anyone? 1-0. If S is 1 and R is 0.
Q is 1 and Q bar is 0.
What is your good name?
Mira.
Mira. Very good. Mira full name. We have multiple Miras.
Mira al-Mahrzi.
Al-Maherzi. Okay. So now I have noted your name. So Q is 1 and 0. And what should I write in the comment? Mira, can you help me now?
Set Q.
Very good. Very good. Very good. Thank you. Thank you. And if you have 0, 0, so Mira, can now you help me? What should you do? What should be my output? Can you tell me?
I'll take the previous answer.
Yes. So it is 1 and 0. Got it?
Yeah.
Okay. So we can say retain Q. And if it's 0, 1, so we are resetting. So we are resetting. Since we are resetting, so Q, what will be the value of what will be the value of what will be the value of reset Q? Yes. What will be the value of Q and Q bar? Anyone may help?
0 and 1.
What's your good name?
Dream.
Reem? No, you're not allowed. So basically, you're already okay. Other than Reem name is already there. Okay. So the reset Q. So since you are resetting Q, it is actually 0 and 1. 1-1. Anyone may answer other than all the student that I mentioned. Anyone? 1-1-1. What will be the output? 1-1. I'm giving an opportunity.
0, 0.
What's your good name?
Mira.
Mira. Okay, very good. So now we can see here it will be actually 0-0. And we call this as invalid combination. Okay, now it is 0-1. So 0 months means we are resetting Q. So we are already resetting Q. So it's resetting Q. So the output will be 0 and 1 because we are resetting. Got it or not got it? Okay, if it's 1-1, the output will be 0-0. It is an invalid combination. And if it is 0 0, here now the problem is this. So here then we will have, we do not know. So this will be a race condition. So this will be a race condition. We do not know. The output can be either 0 1 or output can be 1 0. This called is the race condition. So when this 1 1 is followed by this thing, so it's a race condition. 0 1 0 1, when we are resetting, it will be 0 1 reset q, and 0 0. So it will change the old value. So it is actually what? 0 and 1. And 1 0, we are setting. It is 1 0. So this is set q. We can retain q. And 0 0 will retain the previous value. It is actually what? It is actually 1 and 0. Any question? Any question? Any question? Got it or not got it? And please fill the table. This may be the question in exam. So fill the table. This may be the question in exam. So this may be the similar question in exam. So you can then fill the table. Is it clear or not clear? Yes. So what
Clear.
I'm going to do?
Clear.
Yes. So now what I'm going to do? So now we have this thingy. So now this is how it works. So now this is the now we're going to have the timing diagram. So for the timing diagram, okay, can you see here now what is my S here in this time, during this time this? So here if you look at this time, during this time, S is 1 and R is 0. When S is 1, so basically what we are going to do, so basically S is 1 and R is 0. Got it or got it? So this is actually S is 1 and R is 0. So this will go there, and Q will be 1 and R will be 0. Got it? Then we have no change. It will retain its previous value. 0 0. It is 0 0. No change. So this 1 will remain as 1 and 0 will remain as 1. It will retain its previous value. Now in the next cycle we are resetting. Since we are resetting, so reset will dominate. So reset will dominate. So the path will be from here. So Q bar will be 0 and Q bar will be 1. So Q will be 1. Q will be 0 and Q bar will be 1. No change. It will retain its previous value. So no change. This is 0 0. Here we have 0 0. No change. So it will retain its previous value. This will be previous value. So I may give this timing diagram in the exam. So can you see here? In this case, the input is 0 0, but here the output is 1 0, and here the input is 0 0, but here the output is 0 1. So what does it implies? We have the same input, but we have different outputs because of the feedback path and because of the previous states. And can you see here now? Here now we have an undefined state here. We have undefined state 1 1. When we have undefined state 1 1, the output is 0 0, and here there is a race condition between q and q bar. We don't know the expected output. The output can either be 0 or output can be 1. Any question? Any question? Clear or not clear?
Clear, Professor.
Very good. Okay, now what you are going to do? So now what you are going to do? So now we are using a gated SR latch. This is the gated SR latch. So this is the block diagram of a gated SR latch, and now I'll explain this with the gated SR latch. Can you tell me? Can you tell me the block diagram of a gated SR latch? What are the inputs and what are the outputs? Anyone may answer.
Input is R, S, and E, and output is Q and Q bar.
Very good. So Sidra?
Yes.
Okay. So it's your first response. Very good. So now if you look at here, what you are going to do now? So now if you look at the block diagram of this gated SR latch, so this is gated SR latch. So the input are R, E, and S, and the output is actually Q and Q bar. Clear? Okay, now if you look at here, so anyone draw the truth table for this? Anyone will draw with the truth table for this? Yeah. Can anyone draw the reduced truth table? If anyone will draw the reduced truth table for this, may get some points. Okay, now look at this thingy. How many inputs are there? There are 3 inputs. So can we say this input is E and S and R. Okay, and then we have QT plus 1 because we are interested in QT plus 1. And then we have QT plus 1. QT plus 1 is actually the next value. Okay, let us assume. Okay, so let us assume that we have E0. When E0, it means that this is E stand for enable. So when E0, independent of the value of R and S, both of them will be ignored. So what will be QT? So QT plus 1 will be QT and QT plus 1 bar will be QT plus, sorry. So we call this as what? Retain the previous value. Got it or not got it? And now if we have an enable signal, let's assume we have an enable signal of 1. So then the latch will operate as normal. If it's 1, so 0, 0 and 0, 0. What will be the value of QT plus 1 and QT plus 1 bar? And anyone may help. Anyone may help. I'm not giving any answer. You don't want to get any?
QT and QT bar.
Yes, it will retain its previous value. QT and QT bar. What's your good name?
Dream.
Reem. So retain. Because it's 0, 0. Since 0, 0, it's retained. Okay. What will be the value of this thingy? Anyone may help. So if it is 1 and it's 0, 1. What is the value of QT plus 1 and QT plus 1? Anyone may answer. Quick. 5 seconds. Why? You forgot the operation of a latch? Latch is enabled.
Was it 0, 1?
Yes. Why 0, 1?
Because reset is on.
Reset EQ. You answered, didn't answer me in 5 seconds. So now I will have now 5 seconds now. 5 second margin. 1, 1, 1.
0, 0.
Mm-hmm. Yes, what is your good name?
Thomas.
Thomas. It's your 5th response now. So now if you look at here, 1, 1, so it means that what you are going to do. So basically if it's 0, 0, it is invalid combination. And what about the blue color? So now let's start with the blue color. So blue color 1 and 1, 0. Help me.
1 0 and set Q.
1, 0 set Q. And what will be the QT plus 1? And QT plus 1 bar.
1 and 0.
What's your good name?
Rex.
Rex. The second response from you. So it is actually 1, 0. Any question? So this is the block diagram of a gated SR latch with an enable signal. Got it or not got it? Okay, now let us assume. Okay, now this is the thing that we did it. Okay, no problem. Let us assume that we have E is equal to 0 and S is equal to 1 and R is equal to 1. What will be my output?
Don't care.
What will be QT?
QT and QT bar.
What will be the value of qt? And qt plus 1 whole bar. Anyone may answer?
Is it Qt and Qt bar?
Yes. Why? Because this is the same thing as this thingy. Here it is E0, NS is 1, and R is 1. We ignore S and R. It's the same thing that most of the students are ignoring me during my lectures. They are not answering me. They are not responding to me. Like just like I'm the poor guy who is being ignored so many times. Okay, so this is QT. So this is actually QT and QT. Let's assume the value of E is 0 and S is equal to 1 and R is equal to 0. What will be the value of QT plus 1 and QT? Anyone may answer?
QT and QT bar.
Yes, QT and QT bar. Not this is actually, so I can remove the bar here. Sorry, this bar is a mistake. Clear? Any question? Any question?
No, Professor.
Okay, now what are we going to do? So now with this is get it as our latch. So now we have this thingy. Okay. So let's assume we have, now we want to draw this. So we have this get it as a latch. So we have E, then we have S, then we have R, then we have QT plus 1, which is actually now we have QT plus 1 whole bar. 1 0 1. What is the output?
0 1 reset Q.
Yeah, very good. So you know I can you see here? So this is actually, if you look at the output, so the output will be now very good. That's very good. You know, you're paying attention. And I should have introduced this bonus much before. So you see, reset Q. And again, let's zoom in the next cycle. We have E0 and 1 and 0. What will be the output?
QT and QT bar.
What is that value in this example?
0, 1.
Very good. So now you can see we keep the old value 0 1. Please remember, this is a little tricky. So this was considered, can you see, this was considered as a set operation. But now the problem here, the enable is 0. So we enable is 0, it means the set operation will be ignored. In a similar way, anyone may answer. He may get, I'll notice. In a similar way, who is ignored in the class? I may get some bonus points for the student who did answer. And other than who answered. In a similar way, who is ignored?
Professor, you.
Yeah, what's your good name?
Zafar.
Zafar? Okay. Similar way. Okay, apart from all the jokes. And so can you see here? So now even retained its previous value. So it is actually retained. Any question? Any question?
Professor, but isn't if E is 0,
When E 0, so in the next thing, when E 0, so all the operation will be enabled. Please remember. Now, Sidra, why did you ask this question? Now I will give you this thingy. Okay. Please remember, when E is equal to 0, so basically this is very important. This is very important. So you ask this question. Can you answer this question? If you answer this question, then I may give you another bonus mark and like one and note your answer. Yes, Sidra, can you tell me why it's like this?
I don't know.
No, it's there in the figure. Look at the figure. Please look at here. This is very important. And why I'm going to do that? So basically, now I'm making another thing, and I will. Can you answer me? This is a very tricky question. This is a very tricky thing. Can you see here? Now look at here. So now what I'm going to do? So I'm now making it big. Now why I'm making it big? So basically, this is. Please remember, this is actually. This is the same thingy. Remember, this is the same thing as SR latch or not? This is S, and this is R. Am I
Yeah.
right or not? And since we
Yes.
enable, so when enable is equal to 0, when enable is equal to 0, this is an AND gate. Any input, okay. So basically, whatever the input R, so this is R dot 0. What is the value of R dot 0? Anyone may answer. 0.
0.
And then when enable is equal to 0, this is actually S dot 0. And which is this is actually S dot 0. When edges are 0, what will be the value of CS? CS will be 0. When both of them are 0, R is 0 and S is 0, it will retain its previous value. You got it or not got it?
Yes. Yes, Professor.
You got it. So that's
Yeah.
the whole idea. That's the whole idea that we can see that you can why this enable thing. So please look at the block diagram and see the pattern. And based on this pattern, we can see. Oh, now this is an enable signal. So basically, this is the original SR latch. And this diagram, whatever is this thing, is actually the enabling circuit. And when e is equal to 0, it will make the original S to be 0 and R to be 0. And when S is equal to and R is equal to 0, so the original, the next thing. So it R is equal to 0, it returns its previous value. Any question? Any question?
No, Professor, it's clear.
Now I will explain this with an example. So let's assume I will explain this like this is like enabling and disabling this the thing. So basically, so I will explain this with an example, and you will also laugh at that example. You student already know it. So when you are in the online exam mode, your cheating mode is on. Okay, and now when you're face to face, so the cheating is enabled. And when you are in face to face exam, the cheating mode is disabled. You got it or not got it? Good example, bad example.
Good example, Professor.
Good example. That's good. What's your good name?
Movie.
Ovid.